And welcome to the Daily Space Weather. I'm your host, Dan, a.k.a. smAsho. Thanks for tuning in, folks. Today we're going to be talking about geomagnetic unrest, a condition that the Earth is currently in. An auroral forecast will be coming up. There's a new playlist on the channel, and FILAMENT. First, we're looking at the sun in 171 angstroms. And I would note that around where that coronal hole is located in the lower left, there is a significant plasma filament down there. No coronal mass ejections to report on today's daily space weather video. Here's 304 angstroms. And that filament is around this area, right in here. And we will let you know on the channel if that releases, and if so, where it's headed. So we've already got a coronal hole wind stream coming in from this coronal hole up here in the north. It arrived a little more quickly than expected, possibly because some sort of electronic bridging effect happened as a result of the last coronal hole wind stream. But in any case, it's here. It's not all that high speed, but it's striking pretty hard on the magnetosphere. And here's a view in 6,562.8 angstroms, one of the emission spectral states of hydrogen. And this hydrogen alpha imagery is from El Teide, Spain, part of the National Sunspot Observatory. This data only 1 minute and 21 seconds old. And you can see some evidence of filaments here and here in between Earth and Sun. And again, we will let you know if those happen to release. Next, we'll show you a diagram of the solar system, as many of our viewers are interested in where things are located. Within the heliosphere, there's the current situation. And there's where things will be in a week, approaching another another full moon. And I like to use in-the-sky to see what stars are overhead. There's the current situation. Put in your location if you want to build your own sky chart. The 10.7 centimeter radial flux all the way down to 70 solar flux units. It's solar minimum conditions. And there you can see that in context. The 1 year chart of that. Levels that we saw as long ago as 1 year ago. Just about where they are now. 70 solar flux units for the 10.7 centimeter radial flux, the radio output of the outer solar corona. And if you're new to the channel, you may not know that the 10.7 centimeter radial flux follows sunspot number quite exactly. There is sunspot number progression, and when there are no sunspots, one of the ways we measure solar activity is through the radial flux. We don't typically see big increases in the radial flux without sunspots. There's the radial flux progression. And again, super proportional to sunspot number, discovered in 1947, the 10.7 centimeter radial flux. Next, we'll check out what volcanoes are erupting. Interesting cosmology segments for you today, some further reading if you like. What's erupting? Well, Sakurajima's erupting. Although volcanic ash not identifiable in satellite imagery, please do not attempt to fly your hang glider or home-built kit ultralight aircraft over the caldera. It could be unhealthful, and we need the YouTube views. Raung in East Java, also erupting. I think that's an uptick at Raung, or maybe not. Anyway, flight level 140 there at Raung on East Java. It's a 14,000-foot ash plume. Popocatépetl exploding. Volcanic ash plume to 20,000 feet there. Fuego. So the lava flow in the westerly direction has ceased. A second lava flow remains active. Some Strombolian, Vulcanian type explosions at about 12 to 14 per hour, generating plumes to about 15,000 feet of altitude. Volcanic ash being dispersed toward the northeast and northeast to about 50 kilometers from Fuego down in Guatemala. Sangre exploding, 22,000-foot ash plume above the Ecuadorian volcano, and Sabancaya exploding as well. 22,000-foot ash plume as it explodes as well in Peru. Please do not attempt to do a back handspring over that caldera. Let's see which earthquakes make the list for the past 24 hours. And we see some deep quakes here, including this 4.7 at Chile, this 5.0 north of New Zealand, this 4.9 at Vanuatu, not far from the last deep quake we just reported. Also a 4.3 at Argentina at over 200 kilometers depth. A deep quake at Peru at over 148 kilometers depth. A deep quake at Argentina at over 240 kilometers depth. It's a 4.3 magnitude. So no major quakes over the past 24, but lots of deep quakes. Here's another deep quake in western South America, that one in Peru, a 4.6 magnitude at 99.6 kilometers. Here's a 4.9 at the Kuril Islands south of Kamchatka. It's a 4.9 magnitude at 107 kilometers. Largest of the past 24 appears to be this 6.2 at Vanuatu. That one near the surface at an estimated depth of 10 kilometers. And you see some aftershocks there. Here's a 4.6 at Costa Rica. Not every day you see a Central American quake. Another deep quake in western South America at Bolivia. It's a 4.1 magnitude at 168 kilometers. A 4.4 at nearly 200 kilometers depth at Bolivia. A 5.1 at depth at Vanuatu. And coming in at 3:42 Universal Time, a 5.1 at Indonesia at nearly 600 kilometers depth. It's a significant deep quake event. Speaking of deep, our streams are pretty deep. This stream is brought to you at twitch.tv/smashamash. Thanks to our subscribers over there. Perhaps check out the mobile app. It's fantastic, and twitch.tv is a wonderful live streaming platform. It's why we use it on the regs. twitch.tv/smashamash. Also, make sure you follow us on Twitter if you don't yet. We've put 2 links up there. If you'd like some links about some cosmology subjects, we put 2 links up here by Mr. Eugene Bagashov. One of them is about Anthony Peratt's book, and the other one is about Hannes Alfvén's book. More on that later. Twitter.com/smashamash. And again, thanks everybody for tuning in. If you're viewing on YouTube, please don't forget to press like and subscribe. More on that later. Also, don't forget to check out our own website, smashamash.com. We saw the writing on the wall a couple of years ago, and we decided to create our own website because, well, we saw big tech self-destructing since 2016, damaging its own credibility and yours if you trust those organizations like Google, Facebook, Apple, Twitter, and Amazon. Today's featured product is available at the smAsho store, which you can link right from the homepage. It's the Mansa shirt, which is totally nonpartisan, by the way. It stands for Make America Not Suck Again. Have you noticed that your local situation has sucked lately? Well, it's up to you to make your situation not suck. We also have a Mensa shirt, which stands for Make Earth Not Suck Again. Maybe we'll put that back up again, but for now, Mansa. We invite you to Mansa. Make America not suck again, because it's up to you, not the government, as you may have noticed. Again, don't forget to press subscribe on YouTube. If you're viewing the content over on YouTube, press the notification bell, press share. Tell your friends, foes, science noobs, and science pros about the content. Visit our links, etc. Again, youtube.com/smashamash. There's a new playlist up there as well. youtube.com/smashamash/playlists for all of our playlists, which have all kinds of subjects besides daily space weather. Thanks to our subscribers over at BitChute as that subscribership continues to grow. Thanks most of all to our patrons, the true source of funding for the content, as we're paid almost nothing to make these videos on YouTube. So again, please share. Please tell your friends and foes about the content. even tell your neutrals, as the algorithms do not seem to like us. Thanks, patrons. Please consider becoming a patron for early alerts before anybody else on Earth at patreon.com/smAshomash. And let's do another cosmology segment. Now, we like to talk cosmology regularly because it is a perfect example of a science that it is in the process of being rewritten. And so we talk about it all the time, as there are all kinds of articles coming out and all kinds of interesting facts. Let's talk cosmic rays. Cosmic rays are typically particles coming from outside the solar system, from different stars and indeed different galaxies. When cosmic rays strike things, they create secondary particle showers. So let's just say that this right here, let's say this is a hydrogen nucleus, right? Hydrogen nuclei are the most common type of cosmic rays, as well as the most common component of the solar wind, making up about 90% of the solar wind. When a cosmic ray strikes the Earth's atmosphere, it's going to make it through until it starts striking things. And when it starts striking things, it'll probably steal an electron, and then it's going to create an ion from that stolen electron, and that particle is going to want to do a chemical reaction with something to either give up another electron or take an electron back. Meanwhile, you have what we call an ionization pathway. And this process, as protons traveling at nearly the speed of light are decelerated as they hit the atmosphere, these cause clouds to form. So if you want to read about it, there's an article on space.com that we've actually featured here. Space.com, What Are Cosmic Rays? That's from 2018. Perhaps have a read on that. Cosmic rays are super important in climate, and they're not yet figured into climate models as far as I know, in that in 1996 the Svensmarks discovered that cosmic rays cause clouds to form. Clouds tend to form on these ionization pathways, and you can find all over the internet information about the way water reacts. So if water is exposed to a positive anode, water is pushed away from the positive anode. And if water is exposed to a negative anode, with current, of course, in both instances, water is pulled toward the negative anode. So as you could imagine, that would affect the Earth's atmosphere, and indeed cosmic rays do. They have the ability to make the Earth cloudy over an extended period of time. So let's look at some cosmic ray monitors. We do this about twice a week. Here is the neutron monitor at apatity, and you can see a downward trend here over the past 30 days at apatity. And at Barentsburg, also a downward trend there over the past 30 days. Let's go someplace farther south. How about Athens, Greece? Did I fail to show that? I failed to show it, folks. I apologize. Back to apatity and Barentsburg. So there's apatity. You can see that 30-day downward trend. And here is Barentsburg. There's the 30-day downward trend at Barentsburg. Next, Athens, Greece. Let's try this again. There we go. There's Athens, Greece over the past 30 days. Slight downtick at Athens as well. So despite this very weak level of solar activity, cosmic rays seem to still be going down. Mexico City's flat here over the past 30 days and down over the past 2 weeks. And next we'll go to Oulu, Finland, and 2 Antarctican monitors. There's Oulu. Downtick at Oulu over the past 30. Here's DOMB Antarctica. A downtick at DOMB Antarctica over the past 30 days. And there's DOMC Antarctica, a downtick there as well. Now, I talked about Twitter. The only place I put these links were on the Twitter feed. You can find them on the Thunderbolts.info forum as well. Mr. Bagashov created like his cliff notes for Anthony Peratt's Physics of the Plasma Universe, a book he does not like, as well as Alphane's Cosmic Plasma from 1981, a book that he does like. If you'd like to read those books without entirely reading those books, perhaps check out Eugene's synopses here. Thanks to Eugene. Hit me up, we'll make that coronal holes video at your leisure. Now let's pick a random object here. We're going to use our random quantum number generator here. Anu.Korn. We're going to pick a random number between 1 and 1031, which will coincide to an object at Neil Garrel's Swift Bat X-ray Observatory. Today's random number is 899. Let's see what it lines up with. 899 happens to be 1ES1959 plus 650, a BL Lacertae object, a type of quasar, which has a broad band emission spectra. So BL Lacertae objects, instead of only showing up in one frequency, they show up across the entire electromagnetic spectrum. And 1ES1959 plus 650 is a consistent X-ray source, as you can see here. No apparent cycle with it. And there's the last 30 days of that. Let's see if we can get a glimpse of it on the SIMBAD. And there is that BL Lacertae object, a type of wide emission spectral band galaxy. So it's a type of active galactic nucleus where you're looking right down the poloidal field. And what I mean by that is if this was a spiral galaxy, there's a field coming out of the galactic core of that galaxy. And depending on your location, you may be looking right down the pole. If you're looking at it more like kind of from the side like this, that field is going to come out in this sort of direction. And if you're inside that jet, the galaxy will be a quasar, a quasi-stellar object, as they're still called. We now know what they are. It's just a matter of perspective. So there's a view of that 1ES 1959 plus 1650. Let's look at it on Aladdin Light and see if we can see it in a couple different spectral bands. Here it is on the 2-mass. That is infrared light. And we'll see if we can see it on the XMM. There it is on the multi-mirror X-ray project, the XMM Newton. And it doesn't show up on Chandra. How about the Swift Bat Flux? It does show up as a bright spot there on the Swift Bat Flux. And we'll go back to the 2-mass here. So we'll zoom way in. And there's quasar 1959 plus 650. Today's featured object, 1ES 1959 plus 650, the featured object on today's cosmology segment. Let's get back to current data. A tiny solar flare occurred as we did the show. Check it out. It's not even a B class. Solar activity ultra flatlined here over the past couple of weeks. And you can see over the past 3 days, no solar flaring. Let me just check the life of the stream here. Again, we are streaming live. And it looks good to me. Here's the proton flux, and we don't see any coronal mass ejections striking the magnetosphere, so as expected, no spikes in the proton flux. Next, we'll go to the real-time solar wind, and I will vanish, so you can see the whole chart. There's 1 day of solar wind, and this little weak coronal hole wind stream here, it only made it up to not even 400 kilometers a second, only to about 370 kilometers a second. So this is a little bit early for a coronal hole wind stream arriving. I was expecting this to be here more like tomorrow, but in any case, we see it's already subsided a bit, maybe coming back up again. I would expect this solar wind density to drop down before this strikes in earnest. And I would expect us to get in geomagnetic storm conditions. Patrons were already aware. Patrons who decided to send us a few bucks per month and open their cobweb-encrusted, they're now no longer cobweb-encrusted wallets and send us a couple bucks per month for early alerts. would have already known about the geomagnetic unrest situation that Earth is currently in. I would expect this to make it all the way into geomagnetic storm, as we haven't even seen the density drop off. So this is certainly the leading edge of that coronal hole wind stream. Current solar wind density 15.81 protons per cubic centimeter. Current solar wind speed 353 kilometers per second. So you can see there for the last 6 hours, geomagnetic unrest conditions. And we're going to show you all three of the geospace magnetosphere movies today. First, the velocity. And you may be freaking out by looking at this high velocity area right here and saying, oh my God, Nibiru must be back there. But that's quite the opposite of what's going on, because that would be plasma being reintegrated into the high-speed solar wind. Next, we'll show you density. I thought we'd show you density, but apparently not. It's pretty uneventful, folks. It is a dense region around the Earth right now. We'll show you pressure. And let me just bring that back. So here's the magnetohydrodynamic pressure. This is 4 hours of data. Keep in mind this is a model. It is based on a space weather modeling framework, and if you want to read how that's derived, it's got a lot of information to arrive at this model. Go to the Geospace Magnetosphere Movies page, scroll down to Details, click on that, click on Space Weather Modeling Framework, and you can read all about it. Here are ground magnetic perturbations coming a little closer to home. The ground magnetic perturbations at the poles. And we see significant ones here south of South America again, indicating the possibility that the South Pole has split into two as well. There's nobody sailing around boats down there with compasses to refute the data, but the Space Weather Modeling Framework seems to make it look like there may be two South Poles. There are certainly two North Poles, one over northern Canada and one over Siberia. I'll let it play through a second time so you can see that. The South Pole is someplace down here south of Australia. Why are there so many changes in the Earth's B field, otherwise known as geospace delta B, south of South America on the opposite side of the South geographic region? Here's an even better view of that, and you can see a weak spot just north of that as well. So pretty anomalous. We also see magnetic pulses coming out of the northern Indian Ocean and West Pacific. I'll let this one play through a second time as well before we show you the auroral forecasts, which are the next slide. Again, it's 4 hours of data. And you can see approximately where the Siberian North Pole and the Canadian North Pole are. However, the South geomagnetic pole is looking like it may be split, which is what you would expect since the South Atlantic anomaly has split as well. We now have a South Atlantic and a South African anomaly. Here is the auroral forecast, and we'll see where the auroras are best noted. You should see this kick up here in the last bit of the simulation. And it looks like Minnesota might be able to see some auroras there, possibly. Moving on. GOES magnetometer looking weak, and that is because there is a large plasma plume in between the Earth and the Sun. We'll show you it momentarily. We are expecting to see continued spiky readings here and relatively low GOES magnetometer readings. The GOES 16 makes its measurement at around 300 kilometers altitude at the F flare. So here's what we're talking about. This area right here, there is some dense plasma right there. As you can see, all those bunched up potential field surface source lines, they are essentially blocking the Earth's detection of the solar magnetic fields. As the plasma reacts to, is heated up, and aligns to the magnetic fields. Again, we'll keep you posted if it releases. It's part of the reason why we have a channel. We've become the world's leading solar forecaster. Who would have guessed? Not me, but that's what happens in science, man. You ask for the answer to a question, You end up without the answer to the question. You end up with answers to dozens of more questions and dozens of more questions because of those answers. Here's a line of sight field plot. It shows you the poloidal fields in the sun's B field in blue, as well as a solar magnetogram. We'll also show you the coronal hole plot. Again, another large south-oriented coronal hole rotating in, shown in red. And here's the magnetic field plot of the solar corona. We show it daily. It's the sun's atmosphere, and it's a chaotic place. And we can see some north solar polar field lines pointing right toward Earth here. This model shows you open potential field surface source lines in purple or black depending on their location, and it shows you closed potential field surface source lines in pink. If you need to see this diagram for longer, just press pause, leave it on the screen. We don't have time to leave it on the screen. That F over there is the F ionosphere layer where the GOES-16 makes its measurements. Here is another diagram showing you the Van Allen belts as we move into the electrons section of the daily space weather. Again, pause it if you need. That's the beauty of video on demand. We'll be here when you get back. Next, looking at charging hazards. We don't see many charging hazards here, although there are some over places like the Caribbean, Central America, and the Central Pacific, north of the equator, as those electrons are able to charge up satellites and often cause them to shut down if the charges get too high. Here's the 3-day chart of the GOES electron flux, and it's come off the floor a little bit here. We would expect this to remain quite low throughout the coronal hole wind stream. Here's the 1-year chart to put it in context, courtesy Solon.info. Here's a visualization of the total electron content. And the more red of a color you see, the more GPS error you would expect. This is the entire air column all the way up to about 12,500 miles of altitude. Essentially, you're looking at a visualization of the inner Van Allen belt. And we do see more anomalies here at times of low electron flux than times of high electron flux when it is more organized. I would tend to agree with this forecast, which would be the green boxes here. We're going to see slightly lower levels of electron flux here as there is a coronal hole wind stream striking now, placing us in geomagnetic unrest conditions, and we typically see low levels of electron flux, especially during coronal hole wind streams and solar minimal conditions. Here's a visualization of the ionosphere, approximately where the GOES-16 is making its measurements. An ionosphere looking pretty normal now. No real comment there. Let's bring up the latest image. It's from 10 o'clock Universal Time. A bit of a charge up there, making it up to 14 megahertz over places like India and the central Indian Ocean. Check out the weather.gov map. Still quite crazy. All kinds of wind chill advisories, winter weather warnings, all that purple, those are hard freeze. Hard freeze in the southernmost portion of Texas. I saw images of Galveston with snow on the beach. Must be global warming, folks. It's so hot that it's cold. And by the way, there are going to be some circular thermometers coming out later this year to match the circular logic of some meteorologists who claim that it's literally claiming that it's so hot that it's cold, blaming global warming for the current situation. We won't talk about snowfall on this video except in forecast form. Now we're on nullschool.net. We're looking at the 250 hectopascal winds, aka the jet streams, and they're a bit chaotic. Look at the S-shaped bend up here over northeastern Asia. And next we'll look at the Western world's jet streams. And this bend right here is what's causing all these cold temperatures, allowing a low pressure system to drive frigid temperatures from central Canada all the way down into Mexico. Also, extreme meridional jet stream flow around this area, right around the South Atlantic anomaly. And let's look at the snowfall forecast here. On Tropical Tidbits, this is the GFS forecast for snow. We're going to advance this about 3 days. So there's where we expect things to be according to the GFS forecast. At 1800 Universal Time. 1800 Universal Time is 1 p.m. Eastern Time, as Eastern Time is Greenwich Mean Time -5. So the 3-day forecast here, 9 more inches of snow forecasted for eastern Pennsylvania, and a large swath there, with heaviest snowfall showing up in the western portion of Virginia. And any forecast more than about 3 or 4 days out is probably ridiculous and probably should not be covered. Here's a 3-day forecast for snow on windy.com on the Euro forecast. There's where we expect things to be at 1 o'clock p.m. Eastern Time on Friday. The Euro forecast expecting a strong upper level low there to be right off of the coast of Atlantic City. And it looks like the Euro forecast is not particularly agreeing. Oh, yes, it is agreeing. Expecting about a similar amount of snow to the GFS forecast. So things are lining up for a snowy weekend here in Lehigh Valley. If you're wondering where we're located right about there in Lehigh Valley, Pennsylvania. Smash staff and I. The operation includes a whopping 2 people. Again, give Smash staff a raise by becoming a patron or picking up some merch at our shops. And we've got some very active lightning here off the east coast of the U.S. Check it out. A long, long band of active lightning there. Quite far out to sea, though. Those are at like 100+ kilometers off the coast in most cases. I like to use lightningmaps.org when I hear thunder. Next, looking at the cloud layer as we continue on with meteorology, value-added services. So there's what's going on in the cloud layer. A long band of clouds stretching all the way from western Cuba into eastern Canada. Here's the water vapor map as that atmospheric river gets pushed out to the northeast by this dry mass of air trailing it. And this system is going to take its time, and it's going to be an extended period of cold, especially in about this area. Extended cold. And I know the forecasts were showing for like 26 degrees Celsius below normal. That makes for temperatures in Texas. Texas does not handle temperatures of like 10 degrees Fahrenheit very well. And we hope you get your power back on in Texas. I know it's been a disaster down there. We'll show you the power outage map momentarily. First, the Doppler radar, as the system in the northeast is moving to the northeast. There's the situation across the rest of the country. And check out the power outage map. Massive power outages here, and the worst of which are in Texas. Nearly 4 million customers out of power. And of the tracked customers, you're talking about 25% of customers having no power in Texas. Second place is Oregon with nearly 250,000 customers out, probably more than that, as this poweroutage.us map does not track all users. Also Louisiana, Mississippi, Tennessee, North Carolina, Virginia, West Virginia, Kentucky, Ohio, and New Jersey experiencing significant power outages. Ouch. Was I not showing the map? There's the map. Bad times. And thanks for tuning in, Smash Team. Please don't forget to press like and subscribe if you're viewing on YouTube. And don't forget to check out our new playlist. We've got a new playlist. I'm going to play yesterday's video for you. It's the sort of the intro to the new playlist.
So I've got another idea for a new type of segment. We're going to start a new segment on the channel, and it's going to be called Do One Thing.
Because we want you to do one thing, folks. Do one thing. I don't mean one thing. I mean do one thing that's on your list of things to do. In other words, maybe you've been putting off. Thanks Forest Garden for leaving comments. Maybe you've been putting off doing something. Maybe you've been planning on changing your diet. Take one step, folks. The first choice you got to make in any lengthy journey is putting one foot in front of the other. So take one step, make that one step, and we'll be making videos to encourage you to take that one step and telling you about certain steps that we're making. So look for that coming up as a new playlist. Check out our other playlists as well. SmAsho, youtube.com/smAsho/playlists. Again, visit our links, etc. We've got bonus features, so don't go nowhere. Don't go nowhere. Go somewhere. But before you do that, check out the solar intensitygram to see zero sunspots. I think. Looks like zero sunspots to me. And here's the colorized magnetogram. Zero sunspots are the story in terms of solar imagery. And we're going to show you two more animations of the sun here. We're going to show you 335 angstroms as well as, how about 94 angstroms? Some blue and some green. And send us some green by becoming a patron at patreon.com/smAshomash. So here's 335 angstroms. The cool hues of the sun in ionized iron, one of the many ionized iron spectral states, as iron wants a lot of electrons. And here's 94 angstroms, another ionized state of iron. If you want to find out exactly how many electrons it has, go to the SDO data page. There's a little information box that will tell you things like temperatures. It's time for me to vanish and call this thing a day. We got to get it uploaded to YouTube. And thanks to everybody that views our live premieres, etc. Again, if you enjoy the content, don't forget to press like and subscribe. Press share, press the notification bell so that you're able to get notifications when we put up new content. We'll see you next time. May that solar wind be at your back, and may that covidiocy absent from your doorstep.
Just a good old smash, never meaning no harm. Beats all you never saw, been in trouble on social media since before its existence. Straightening facts, smacking down hacks. Someday our viewers might get me, but pretend never will. Making my way the only way I know how. That's just a little bit more than big tech will allow. Just a good old smash, wouldn't change if I could. Fighting the nonsense, it's a neo-renaissance in the hood.